Really quickly in this video, I want to go over Rolle's theorem, and then I just want to apply it one time easily. I want to remind you that when on the AP exam or in college calculus, you're not going to be asked to use Rolle's theorem as much as they're going to use this term, a guarantee, and that you're going to be asked, is there a guaranteed value? And as soon as you start to hear the word, or start to read the words guaranteed value, you have to think intermediate value theorem, Rolle's theorem, or mean value theorem. In this video, we're going to cover Rolle's theorem a little bit. Rolle's theorem, if you'd let me illustrate this with you, I'd just like you to put a point somewhere on your paper, so maybe here. And I don't care where you put it, but what I'd like you to do now is just move to the right of that and then make another point that's the same height. So there's another point, and if I'm just asking you to believe that this point and this point have the same height value. And now what I'd like you to do is connect these 2 points with any function you would like to. So it has to be a function, but other than that, there's no restriction. So maybe I'll make mine a little bit, I don't know. I was thinking I'll make it sinusoidal, but whatever. Maybe that's not so sinusoidal. But there's my, you can connect yours any way you want. So see what you get. Now what I'm saying to you is this. Rolle's theorem just says if this value A and this value B have the same height, so if A, this is f of A, and this is B, f of B. And all Rolle's theorem says is that if f of A is equal to f of B, and there are some conditions about continuity and about differentiability, etc. But leaving those things aside for a second, saying that if f of A and f of B are equal, then there's some point on this interval between A and B where at least one place in this interval between A and B where the slope goes to 0. And in my case, the slope goes to 0, I don't know, goes to 0 there and there. So in the case of the little function that I drew, the slope goes to 0 twice. And if you look at yours, it went to 0 somewhere, didn't it? And maybe you said, well, yeah, Charlie, I made a horizontal line. So maybe your function looked like this. And you're like, I have a horizontal line like that. Well, you can compare that one. Isn't it true that the slope of this function is 0, not just in one place, but in every place? So Rolle's guarantees that at least in one place that slope goes to 0. And you can look, and you can draw any function you want, and no matter what you do, you'll see that at least at one place, the slope will go to 0. So that's what Rolle's is saying. So here's an example of Rolle's. Let's say let f of x equal x to the fourth, I guess. I'm trying to do this as quickly. 2x squared. And then I'm going to pick something that I know is true on negative 2 to 2. And what I'm going to ask, is there some guaranteed value on this for this function on this interval where the slope of this function goes to 0? And all you have to do to declare that you're going to use Rolle's is this. And I'm approaching this as if I'm taking the AP exam. So I'm going to take f of negative 2. And f of negative 2 is negative 2 to the fourth power minus 2 times negative 2 to the second power. And we find that this is equal to, was it equal to 8? It's equal to 8, and so we're going to try f of 2, and f of 2 is 2 to the fourth power minus 2 times positive 2 to the fourth power. And you can see what's happening here is that when you raise either one of these numbers to an even power, the answer here comes out even. So this is also equal to 8. So now to declare that I'm going to use Rolle's theorem, I'm going to say this. I'm going to say f of negative 2 is equal to f of 2. Therefore, yes, by Rolle's theorem. And it may be on the AP exam, on a free response, that all they ask you is there a guaranteed value? Not what is the guaranteed value. And if the question is there one, then you can stop right here. And you can say, yeah, f of negative 2 is equal to f of 2. Therefore, yes, by Rolle's theorem. You don't have to go through and say Rolle's theorem says let f be a continuous function on the closed interval ab and differentiable on the open interval ab. If f of a is equal to f of b, then there's at least one number c. And you don't have to quote all that mess. You just quote Rolle's, and that's a good enough answer. So they're not asking you to quote Rolle's verbatim, but just to say declare Rolle's. However, once you do this, this is a green light for us to move forward. Now I am, because I know I can use roles, I'm going to take f prime at x, and that is equal to 4x cubed minus 4x, right? Remember, Rolle's guarantees that there's a slope of 0 somewhere. So I'm going to set this thing equal to 0. I'm going to factor out 4x here, and that leaves me with x squared minus 1 here, doesn't it? Is equal to 0. And I'm going to solve this, and I'm going to get x is equal to 0. Remember, this is difference of squares, isn't it? So this is x plus 1, x minus 1, right? So that gives us x is equal to negative 1, or x is equal to 1. So here are my guaranteed values. So I'm going to say that x is equal to 0, x is equal to negative 1, or x is equal to 1 are values, because I'm holding my reader's hand for this AP exam because I want to help them to give me the points I deserve, are values guaranteed, because that's their word, guaranteed by Rolle's theorem. And then I'm going to circle that answer. Okay? So that's what I would do to get as many points as I can on the AP exam. I'm going to go through. I'm going to follow the directions that were given to me. I'm going to realize that when I read the word guarantee on the AP Calculus exam, it's probably talking about one of 3 theorems: intermediate value theorem, mean value theorem, or Rolle's theorem. And we just covered Rolle's theorem. And I'm going to do more problems on this, so I really hope it was helpful. Thanks for watching.